Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now we will see the chapter Matter in Our Surrounding, that is for class 9. It is part 3. In part 3 I want to explain effect of pressure and temperature on the states of matter. In previous video I told there are 3 types of matter that is here, states of matter, that is solid, liquid and gas. So if solid, liquid or gas are there, then what happened about pressure and temperature? You know, when you are giving pressure to gas, it changes to liquid. So similarly, if you increase the temperature of liquid, it changes to gas. So here indirectly you can observe by giving pressure, by giving temperature, the states of matter changing. First we will see what is the effect of pressure on the gas state. If you are giving pressure, automatically it will contract, it will come to very small place, it can be placed in a small cylinder, also in small area of container that is also occupied by the gas. If gas particles move with high speed, what is the nature of the gas particles? That will move with high speed. During the movement here, what happened? The particles hit each other and also the walls of the container. That means, gas particles move with a high speed, and whenever the gas particles move with a high speed, what is the nature then? The particles hit each other and also the wall, the container of the wall, there also it will strike. Then what happens? Here what it will produce after hitting? Then here you can see the pressure exerted by the gas particles per unit area, that is called during the movement, the particles hit each other and also the walls of the container. The pressure exerted here by the gas particles per unit area on the walls of the container. That means indirectly you can say what is the pressure, the gas particles, the pressure exerted by the gas particles per unit area on the walls of the container. Then matter changes its state. You know there are 3 states of matter: solid, liquid and gas. Then what happens if you are giving some pressure, some temperature, then only the matter changes its state. Then how? You know there are 3 states of matter as solid, gas and liquid. Water exists. Suppose you want water, you see water. What is the condition of water? That is liquid form. If you cooling, then what is the form? That is ice, solid form. If you heat, it changes to water vapor. That what is the form? Gas form. That means simply water, if you take, you can observe there are 3 states. On cooling, ice, solid. On heating, it changes to it changes to gas, that is water vapor, that is gas condition. And simply what we want to see, that is the liquid one. Suppose you are taking water in a beaker and starts heating. On heating, what happened? On heating, here on a low flame you take, note the temperature when the ice start to melt. That means you observe when you heat the ice, it starts to melt. And note the temperature, observe the temperature. What is the temperature here? When the all ice is converted into water, first you will heat the ice. You can't observe that whether all ice are melting or not. But when all ice starts to melt, and then note the temperature and how the ice converted into water. What is the temperature at which the ice is converted into water? On heating, start the liquid. Suppose liquid on a beaker, on heating what happens here, water starts to boiling. Noted the temperature. That means when ice starts to boiling and all ice start boiling, ice starts on heating, it will melt. It changes to liquid. Similarly, water on heating starts to boiling and gives the water vapors and temperature noted. That means when ice starts to melt, you note the temperature. When all ice has converted into water, note the temperature. Similarly, on heating, start the liquid until the water starts to boil. When starts, remember, when starts, this note the temperature. When all the water or liquid has vaporized at the time, note the second temperature. That means you will note maximum 4 temperature to know the value of the temperature on the states of matter. First, when ice starts to melt, note the temperature. When all ice has converted, note the temperature. Similarly, liquid on heating, it starts to boil, it starts to give vapor, then note the temperature. When all the liquid or water change to vaporization, change to vaporized, that is water molecules, at that time also note the temperature. What is conclusion? Conclusion is on heating solid, because first you will see solid, temperature increases, and what happened? Kinetic energy of the particles increases. Kinetic energy of the particle increases. And then the particle starts vibrating. When kinetic energy means movement energy. When the kinetic energy increases, they starts to vibrating and with the greater speed. That means movement of the particles is very important. So when heating is there, on heating what happens? The solid particles, their kinetic energy increases, vibration increases with greater speed. Then molecules, the particles, they will start vibrating. Energy supplied by heat, then you are supplying energy by heat energy you are giving, and it overcomes the force of attraction between them. When the solid particles are close each other, that is giving as a solid state. When you are giving energy by heat, it overcomes the force of attraction between the particles which trying to close in a small place to become a solid. The particle leave their fixed position. Then what upon vibrating and speed is more, their own position, their fixed position, that is disturbed. They want to leave and start moving more freely, because there is no force of attraction. Force of attraction is very, very less than kinetic energy. So stage is reached, solid melts and is converted into liquid. When starts moving very freely, and here force of attraction become less and less, and kinetic energy more and more kinetic energy, so and changes to liquid. What is melting point? Melting point means minimum temperature. Minimum temperature at which solid melts to become a liquid. That means when you see at this temperature, solid melts to liquid.
Okay.
At the atmospheric pressure. So example, melting of ice, it is 273.15 Kelvin, and Kelvin always represented by K, and here this is 273.15 K. So if you see that means 7-point fusion. What is meant by fusion? The process of melting from solid to liquid state. You know, when this solid changes to liquid by giving temperature, vibration increases, movement increases, movement is free. At the time the liquid state it changes, it gives the idea or knowledge about the fusion. Latent heat of fusion. What is meant by latent heat of fusion? During melting of solid, when you know on heating solid changes to liquid. Let us example ice. The temperature of this solid does not change till all the ice melts. That means you see here it is started melting on heating, and here you will observe the temperature of the solid does not change till all the solid melts. That means melting. Suppose you think 1 hour required to melt 1 kilo of ice later, then what to do? You never say that here where is that heating energy goes, because you are heating. you are heating continuously, then here the temperature shows 273 Kelvin, but heating is continued, and unless the whole ice melts. Heating is continued to the beaker by supplying heat. There is no change of temperature unless all the ice changes to liquid. That means here the question is the heating for 1 hour given, where that energy goes. That is called hiding heat energy. That is hiding heat energy. That means what is meaning? The supplied heat gets used up. That means whenever for 1 hour or any time you are heating, means that is used to convert state of overcoming the force of attraction between the particle. That means you are giving energy, that energy, heating energy, that energy used unless all the force of attraction between the particle become less. That means the heating energy overcoming the force of attraction between particles. So heat energy is absorbed by the solid. That means you can say that hiding energy, so that means heat energy what is absorbed by the solid. You can't say where it is going. It is absorbed by the solid without any rise of temperature. So you can say it is a hiding heat energy. It is inside the solid. It is used, absorbed, and that is called latent heat of fusion. Heat gets hidden. I told that heat you can't observe, but it is going hidden and trying to change the solid to liquid until all the solid is there. The heat is always hiding and gives that solid to liquid. When suddenly the 1 kg of ice given later, then it changes to liquid almost, or then suddenly the temperature increases. How can you say, how can you define, how can you explain latent heat of fusion? The amount of heat energy, that means what amount of heat energy you are giving to change 1 kg of solid. Just now I told 1 kg of solid is counted for the latent heat of fusion. Mathematically, how can you say what is the latent heat of fusion? That means 1 kg of solid changes to liquid at its melting point, and the pressure what? Atmospheric pressure. At atmospheric pressure, and the 1 kg of solid undergoes to liquid, and that energy, heat energy, which is hiding itself, that is called latent heat of fusion. Particles in water, that is 0 degree centigrade, or you can say 273 Kelvin. 273 Kelvin. In Kelvin, it is generally used more energy as compared the particle of ice at the same temperature. That means when particles are there in ice condition, 273, that having more energy than compared to at the same time. Latent heat of evaporation. What does it mean evaporation? That means the liquid changes to vapor. When the heat is supplied to water, let it is example of water. Liquid means it take the example of water easily. So if you take the example of water, particles are moving faster on heating, and other energy, that is hiding energy, it remains in hiding. It is used as a hiding energy itself. So all the 1 kg of liquid or 1 kg of water also, you can say, until it changes to vapor, then only temperature increases. At the same temperature, then what it is indicated? Here 0 degree centigrade is ice, then on heating it changes to water, and water on heating it changes to vapor. Almost all water finish to give vapors, 1 kg of liquid, that is water. This is called latent heat of evaporation. When 1 kg of water changes to vapors, here only you can say temperature increases. At certain temperature, the particles have energy to break the force of attraction of each other. Whenever the force of attraction breaks and only they are free, then only they are going to vapor. Boiling point, what is boiling point? Melting point, solid to liquid. Boiling point, liquid to vapor. The temperature at which at which the liquid starts to boiling at the atmospheric pressure. Remember, in all case, atmospheric pressure is very important, 760 mm of mercury. At that time only you can observe the temperature for boiling point and for melting point. Boiling point used for liquid and melting point used for solid. Boiling is a bulk phenomenon. Now you can observe, you can't say whether it is boiled or not. If one side cannot boil, it is a bulky phenomenon. Mean totally liquid what is given to you, that should be boiled, then only it is called bulky phenomenon. The particles from the bulk of the liquid gain energy. That means when you are giving energy as a heat energy, and that is supplied to the here liquid and gain enough energy to change into vapor state. When it changes to vapor state, then here it should be given enough energy. What is the boiling point of water? 273 Kelvin. What is the 100 degree centigrade? How can you know 100 degree centigrade changes to Kelvin? 100 degree centigrade plus, that is 273. 0 degree centigrade means 273 Kelvin. Then 100 degree centigrade means 273 plus 100, that gives 373. What is latent heat of evaporation? By definition, by meaning, the amount of heat energy required to absorb. Amount of energy required to absorb. What to absorb? When 1 kg of substance. When 1 kg of substance you heat and changes to vapors, it is at its boiling point. Remember, it never cross the boiling point. When under the boiling point, the water changes to vapors. The particles of steam, that is called water vapors, at 373 Kelvin have more energy than at the same temperature than water. Simply liquid and the temperature that 373 Kelvin, what is the energy? That having more energy than at the water at the same temperature. Conclusion. What is conclusion? Particles in steam have absorbed extra energy in the form of latent heat of evaporation. That means latent heat means the energy required to vaporize 1 kg of liquid to vapors. It is absorbed. Solid state into on heating gives liquid state. Liquid state on cooling gives the solid state. Similarly, liquid state on heating gives gaseous state, and on gaseous state on cooling gives liquid state. Are you clear? Solid state on heating gives liquid state. Liquid state on cooling just opposite to solid state, and liquid state changes to on heating gaseous state. Gaseous state on cooling changes to liquid state. The state of matter can be changed to another state by changing the temperature and pressure. So now we will see changing the pressure. How? So here states of matter can be changed into another state by changing the temperature. So it is conclude. Substance around are changed. Here change from solid to liquid, from liquid to solid, liquid to gas on the application of heat. And here the substance around us change solid to liquid form. So you can rub this one. What is meaning of here not required? Then here you can write substance around us change solid to liquid and from liquid to gas on application of heat. Then solid on heating gives liquid, liquid on heating gas. Then Kelvin, what is the unit? That is standard unit, and in standard unit this is called temperature, that is called Kelvin. 0 degree centigrade changes to, that means it is 273 Kelvin. You can say 0 degree centigrade or you can say 273 Kelvin. 0 degree centigrade, that is Celsius scale, and 15 degree centigrade. How can you calculate? 273 plus 15 It gives 285 Kelvin. Are you clear? 285 Kelvin. हेलो, मैं आपको थोड़ा ये जो चैप्टर पार्ट 3 इफेक्ट ऑफ प्रेशर टेम्परेचर ऑन द स्टेट्स ऑफ मैटर, उसको मैं थोड़ा हिंदी में बताना चाहती हूँ। गैस पार्टिकल्स जो है बहुत स्पीडली घूमता है बिकॉज स्पेस ज़्यादा है स्मॉल पार्टिकल से। ये मूवमेंट ऊपर प्रेशर टेम्परेचर कैसे अफेक्ट करता है। जब गैस पार्टिकल्स मूव हो रहा है और उसमें किसका ऊपर हीट कर रहा है, ईच अदर, एक दूसरा से हीट कर रहा है और उसका साथ वॉल जो कंटेनर है वॉल ऊपर हीट कर रहा है, उसको हम प्रेशर बोलते हैं। प्रेशर एक्सर्टेड पर यूनिट एरिया ऑन दी वॉल्स ऑफ द कंटेनर। और मेटल चेंजेस इनटू स्टेट, जो सॉलिड है लिक्विड चेंज होता है हीट करने से, जो लिक्विड है हीट करने से गैस चेंज होता है। लाइक दिस ऑन चेंजिंग द कंडीशन, टेम्परेचर और प्रेशर का कंडीशन चेंज करने से स्टेट्स ऑफ मैटर चेंज होता है। सपोज हम जब आइस को हीट करें एक बीकर में, पहले टेम्परेचर नोट करें। जब स्टार्ट होता है मेल्टिंग, व्हाट इज द टेम्परेचर, और जब पूरा आइस बीकर में है मेल्ट हो जाता है उसका टेम्परेचर नोट करें। दोनों क्या फ़र्क है? जब तक टेम्परेचर और जो आइस है वो मेल्ट न हो जाता है टेम्परेचर चेंज नहीं होगा। और ऑन हीटिंग स्टार्ट द लिक्विड, जो लिक्विड है उसको हीट करें, स्टार करें और बॉइलिंग होते होते नोट करें। और सपोज उसमें बीकर में पूरा वाटर बॉयल नहीं होता है, यू नोट इट। जब टेम्परेचर इंक्रीज होगा इसका मतलब है पूरा वाटर बीकर में वेपराइज हो जाता है। एंड नोट दिस टू फॉर टेम्परेचर क्या फ़र्क हो रहा है। कंक्लूजन क्या है? हीटिंग, सॉलिड को हीट करने से टेम्परेचर इंक्रीज होता है, इंक्रीज करने से काइनेटिक एनर्जी बढ़ता है, काइनेटिक एनर्जी बढ़ने से द पार्टिकल्स जो वाइब्रेशन होता है, मूविंग स्पीड बढ़ता है और वाइब्रेशन भी होता है। वाइब्रेशन होने से जो हीट हम सप्लाई करते फोर्स ऑफ अट्रैक्शन से सप्लाई बाय हीट ओवरकम्स माने ऊपर, उसका ऊपर चलता है। किसका ऊपर? फोर्स ऑफ अट्रैक्शन जो पावर है उसका ऊपर होता है, ज़्यादा होता है। पार्टिकल्स जब फिक्स पोजीशन में रहता है स्टार्ट्स मूविंग मोर फ्रीली, और स्टेज रीच होता है जो सॉलिड मेल्ट होता है और पूरा लिक्विड बन जाता है। और लिक्विड क्या होगा? गैस बन जाता है। जो लिक्विड सॉलिड लिक्विड बन जाता है उसका नाम है मेल्टिंग पॉइंट। जो टेम्परेचर मिनिमम टेम्परेचर जो स्टार्ट होता है एटमॉस्फेरिक प्रेशर में, जो सॉलिड स्टार्ट होता है मेल्ट होना उसको बोलते हैं मेल्टिंग पॉइंट। मेल्टिंग पॉइंट जब तक सही सेम रहेगा, सॉरी इट शुड बी नो डिग्री साइन, बिकॉज here you can observe if you say centigrade, then what happened here? You will put that sign, but Kelvin there is no sign. So what happened? जो आइस का मेल्टिंग पॉइंट, इसको 0 डिग्री सेंटीग्रेड बोलते हैं। इसको यू कैन राइट हियर 0 डिग्री सेंटीग्रेड, ओके, डिग्री सेंटीग्रेड। बट व्हेन यू कम टू केल्विन 273.15 केल्विन। तो फ्यूजन क्या है? सॉलिड टू लिक्विड बनना हीट करने से उसको बोलते हैं फ्यूजन। तो लेटेंट हीट फ्यूजन क्या है? द टेम्परेचर does not change till all the solid changes to liquid, ice to water. That means heating the other heating energy, where it is going, it is hiding itself, it is trying to convert all the solid to liquid. That energy, that heat, that is called latent heat of fusion. The supplied heat gets used up to convert. जो supply heat हो रहा है चेंज क्या कर रहा है? Overcoming the force of attraction between the particles. So the heat that is hidden in the contents, that is called latent heat. Either it is fusion or it vaporization. At vaporization also you can observe liquid to vapor, that is called boiling point. The temperature where the liquid starts to boil, condition क्या है? एटमॉस्फेरिक प्रेशर, तो दैट इज कॉल्ड बॉइलिंग पॉइंट। एंड बॉइलिंग जो फिनोमेना है दैट इज ए बल्की फिनोमेना। बल्की मतलब टू टोटली लिक्विड इट विल अफेक्ट, दैट मीन अननेसेसरली or when you observe the total liquid boils, then it is called boiling the liquid, and boiling point of water always remain 373 Kelvin. You can't observe 373 Kelvin unless the whole liquid will boil. When whole liquid, जब तक पूरा वाटर बिकर में बॉयल नहीं होता है, यू कैन सी टेम्परेचर एज 100 डिग्री सेंटीग्रेड और 373 केल्विन, 373 केल्विन. कब होगा? when all the liquid starts to boil, then only it shows the temperature, that is 373 Kelvin. Similarly, this is called latent heat evaporation. Then come to conclusion. Conclusion क्या है? Solid state heat करने से liquid बनता है, liquid heat करने से gas बनता है, gas cool करने से liquid बनता है, liquid cool करने से solid बनता है. The solid matter can be changed to another state by changing the temperature and pressure. So now how can you convert? कैसे convert करना है Kelvin से डिग्री सेंटीग्रेड से Kelvin. Suppose डिग्री सेंटीग्रेड दिया गया 0 डिग्री सेंटीग्रेड, उसको क्या करना है? 273 Kelvin only. When it is 15 degree centigrade or 18 degree centigrade, what to do? 273 plus 15, or question given 18 degree centigrade mean 273 plus 18. So this is the calculation for Kelvin. I hope this chapter is clear to you, and I myself BL Das, ex-PGT Chemistry, Kendriya Vidyalaya Sangathan, and further I will proceed another video for the last portion, remaining portion of the matter surrounding Earth. And thanks for watching my video. I hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and wait for the coming video. Thanks to all again.